A car with a mass of 1,000 kg, so that's about a small car, accelerates from 0 to 90 kilometers per hour in 10 seconds. What is its acceleration? All right, so let's calculate the final velocity in terms of meters per second. And a kilometer is 1,000 meters, 1 hour is 3,600 seconds. So So to convert kilometers per hour to meters per second, all you do is divide by 3.6. Okay. So we're finding its acceleration, and final velocity is initial velocity plus acceleration times time. And the initial velocity is 0. So 25 meters per second divided by 10 seconds equal to 2.5 meters per second squared. Now, before we go on to part B, all right, let's write the acceleration in terms of g's. So here's the acceleration, and what I'm going to do is do this in a sec. You'll see why I'm doing this. Okay, what is this guy? 1. Very good. Okay. So I'm just multiplying this number by 1. Okay. I'm just writing this in terms of a different language, and you'll see in a second why. So this is and 2.5 divided by that is so yeah. All right, so why did I write it that way? So here's why. What is the weight of the car? It's mg. And the acceleration of the car is 0.26 mg. So, okay, so in part B, what is the net force acting on the car? Net force is mass times acceleration. So that's the force that the engine is applying on the car, and that's equal to mass times 0.26 g, just 0.26 mg. So you see, this force is 26% the weight of the car. Okay. And so that gives more meaning to it. Okay. If so, for instance, when you have a rocket on a launch pad, okay, the thrust that the rocket applies has got to be greater than the weight, okay, and generally the thrust is about 1.4 the weight of this thing. So this car is has got to go a little ways before it becomes a rocket. Yeah. All right. The next problem says, a rocket sled accelerates at a rate of 49 meters per second square. Its passenger has a mass of 75 kgs. Calculate the horizontal component of the force the seat exerts against his body. Compare this with his weight using a ratio. Okay, so here we'll do that. So the acceleration is Okay, so here are the passengers, and here the acceleration is 49 meters per second square. And we'll write it in terms of G's. G. So here's a rocket sled giving you 5G acceleration. Okay. Not everybody gets to ride this thing. This thing is okay. So what does the problem ask? Calculate the horizontal component of the force. Okay. So they want you to calculate the horizontal component of the force. H is mass times the acceleration in that direction, and mass times 5G. Okay. 5 times the weight of the person. Okay. And if you want numbers, you can put in the numbers. M would be 75 kgs, and G is 9.8 meters per second square. And you can calculate that. Okay. Compare this with the weight ratios. So, of course, the horizontal force divided by the weight is 5. Okay. So the horizontal force is 5 times the weight of the person, which that's why we wrote the acceleration in terms of G. Now calculate the direction and magnitude of the total force the seat exerts against his body. Okay. So here's the passenger. You have a horizontal force, and again, I always draw my x-axis like this. There's the horizontal force. What other force is acting on the person?
Force of gravity.
Yeah. So here's the force of gravity. What we're interested in is the force that the seat exerts, and that's equal to the force of gravity. Okay. So the net force on the passenger exerted by the seat is PHY plus F vertical J. 5 mgi plus mgj. Okay. The vertical force is equal to the weight of the guy. So that's the net. There's the force that the seat exerts on him. And now what we want to do is calculate the magnitude of the force and the direction of the force. Okay. So the magnitude is so 5 square is 25 plus 126. Yeah. Okay. And that's mg square. Mg square is common. Square root of mg square is mg. Okay, so the magnitude of the force is square root of 26 mg. So 5.1 mg. And what is the direction of the force? Okay, so theta is F vertical over F horizontal. Okay. So theta is tan inverse of vertical over horizontal force. Vertical force was mg, horizontal force was 5 mg. So tan inverse of 1/5. this works out to 11.3 degrees. Okay, so the seat is exerting a force on the person at 11.3 degrees. Okay. Okay, this problem says the fireman has mass m. He hears the fire alarm and slides down the pole with an acceleration a, which is less than g in magnitude. Okay. So write an equation giving the vertical force he must apply to the pole. If his mass is 90 kg and he accelerates at 5 meters per second square, what is the magnitude of the force he applies? Okay, in cities, land is expensive, so what they have is, in fire stations, all the trucks are parked downstairs, and then the living quarters or the firemen stay up there, okay? And you get a call, a fire alarm, you want to get there as fast as possible. Yeah. Now, what is the fastest way to get down from here to this?
Straight line.
Yeah, so you can jump there, jump down, except that that's not good for your knees. So what they do is they provide you poles that you slide down. Okay? And you don't want G for your acceleration. So you grab onto the pole, you apply a friction force, okay? And there is the force of gravity, and there is the friction force that you apply, okay, to slow down your fall. Okay, so the net force is, and we'll take this direction to be positive. So the force of gravity minus the friction force is equal to mass times the acceleration of the gun. All right, so you see, if this friction force is equal to the weight of the person, then your acceleration will be 0. So you won't fall at all, okay? Assuming you start off at 0 velocity. Okay, so there's write an equation giving the vertical force he must apply to the pole. So for that acceleration, the vertical force is Fg minus ma, which is mg minus a. Okay, if you want that acceleration, that is the force you've got to apply. Okay, that's what the equation is saying. Now, see, if his mass is 90 kg, we'll do that in a second. And he wants the acceleration to be 5 meters per second square. 5 meters per second square is roughly half g. Okay, that's half g. The force you would have to apply is g minus half g is half g, half his weight. Okay. And so all those guys have to be pretty strong to be able to do that. Well, and also one of the reasons why you have to be strong is when that water comes out of the hose, if you don't want to recoil and fly off, you gotta hang on to it pretty strongly. Okay? So the force he'll apply, again, acceleration is 5 meters per second square. I like to write it in terms of G's, so it gives it more meaning rather than just doing numbers. So this is 0.51 G. Okay. So the friction force he's applying is mg minus 0.51 G equal to 0.49 mg. So the friction force is, like I said, 49% his weight. Okay. Okay, this problem says a truck collides with a car, and during the collision, the net force on each vehicle is essentially the force exerted by the other. Okay, so here's a truck colliding with a car. The force that the truck exerts on the car is that. Okay, force on the car, and there is the force on the truck. Now, Mr. Newton tells us that action and reaction are equal and opposite. The magnitude of the forces are the same. So which would you rather be in, the truck or the car?
Truck.
Truck. Everybody knows that. But why? The forces are the same. I'm sorry?
You have more mass protecting you?
I'm sorry?
You have more, like, mass around you?
Right, so the mass, so the force is mass times acceleration. The mass of the truck is much larger, so the acceleration that the truck sustains is much smaller. And high acceleration is what cause damage. Okay, so that's what's happening. Okay. Suppose the mass of the car is 550 kgs. The mass of the truck is 2,200 kgs. See, the mass of the truck is 4 times as great. It's 4 times as great, and so the acceleration is 4 times as small. Okay. And the magnitude of the truck's acceleration is 10 meters per second squared. So the truck's acceleration is 10 meters per second squared. If you're in the car, you'll experience 40 meters per second squared. That's 4 G's. 4 times your body weight. So you'll be pushed back with force 4 times your body weight. Okay? So find the magnitude of the car's acceleration. So since the magnitude of the force, according to Newton's third law, is, okay, so mass of the truck, acceleration of the truck is equal to mass of the car, acceleration of the car. Acceleration of the car will be mass of the truck divided by mass of the car. So if you're sitting in the car, you experience an acceleration of 4.1 G's. Okay. Okay, so let's say your car is stuck on the beach and you have a rope. What do you do to get the car out? I'm sorry?
To get the car up out of the sea.
Yeah,
Pull it.
you pull it. Yeah, that's what we all do. I guess so. Now we'll show you a problem where a more effective way of getting the car out. Of course, you have to have certain things. Okay, so here is a way to do it. Tie the chain to the car and the other end to a tree trunk or whatever, or some immovable object. Okay, so maybe a heavy truck. And then push on the chain like that. And what you'll see is, depending on this angle, depending on how stiff the chain is, if you apply a 100-pound force, you'll get a multiplying factor. And I don't remember the number, but if you apply a 100-pound force, you'll get a tension of 300 pounds maybe. Okay, so force 3 times as great pulling the car. Okay. So this is acting like a simple machine. So what you want to do is, again, you have to have a chain tied to some immovable object and push like that. Okay. All right, so here's how we'll solve the problem. So the problem says the driver attempts to get the car out of the mud by exerting a perpendicular force of 610 newtons. 610 newtons, by the way, is roughly your weight. Okay, so remember your weight is mg, g is 10, and so 600 divided by 10 is your mass is about 60 kgs. And the distance she pushes in the middle of the rope is 1 meter, so that's 1 meter, while she stands 6 meters away from the car on the left and 6 meters away from the tree on the right. Okay, so that is 6 meters and that's 6 meters. Okay, so essentially the rope is a little greater than 12 meters. Okay. What is the tension in the rope and how do you find the answer? Okay, so the force that she exerts, this force is 610 newtons. Okay, so let me show you that. Let's do a diagram. Okay, so this force is 610 newtons. Okay, so what we'll do is, now we'll look at this. So right now this point is at rest. So, and there are 3 forces acting on this link, if you want, or point on the chain. There's tension in this direction, tension in that direction, and this force. So the sum of these 3 forces must be 0. Okay, so and we'll call this T1, T2 because their direction are different, but their magnitudes are the same. Okay, so tension T2 plus F, they should be 0. Okay. The X component of this tension is balancing the X component of this tension because those angles are the same. And we'll find that angle in a second. And it's the Y components of the tension, these 2 Y components, that are balancing this force. Yeah. So that's how we'll find the tension. Okay. All right, let's first find the so that is 1 meter and this is 6 meters. So tan theta is 1 over 6 meters. Theta is tan inverse 1/6. Okay, so this works out to 9.46 degrees. Okay. All right, so now the Y component of this force is tension sine of that angle. Okay, And this y component plus this y component should equal that. Okay? So if you write down the y component of the forces, t sine 9.46 plus t sine 9.46 minus f should equal 0. 2t sine 9.46 should equal f. T is f over 2 sine 9.46. Yeah. And here's what I'll do. I'll calculate this sine 9.46 times 2 and 1 over that. Okay. So let me do that. Okay, so this thing is working out to 3.04 times F. Okay, so what is this saying? The tension in that rope is 3 times the force you apply. Okay. So if you want to pull the car, you can just pull the car straight and you would be applying a force of F. But if you push it like that, now the force you're getting is 3 times the force you apply. Okay? So that's the way to get your car out. So this is acting like a simple machine. Okay, it's a force multiplier. Yep.
So on the other side, you send t sine 9.4, t sine 9.4 minus f equals 0, but all here it says t1 plus t2 plus f equals 0, so how do you get the...
Okay, so this is a vector equation. So these are the x and y components. Okay, so this equation is telling t1y plus t2y plus fy equal to 0. And the f in component is 0I minus fj. All right, so again, you see you're getting a multiplier effect. By pushing on the rope this way, the tension is 3 times this force. So in this problem, it says what force must be applied on a 100 kg crate on a frictionless plane inclined at an angle of 30 degrees to cause an acceleration of 2 meters per second square up the plane. So you want an acceleration of 2 meters per second square. Okay, so there's no friction. This is the force applied. And is there any other force acting on the box? Gravity. Okay, so there is mg acting like that, but what we are interested in is the motion along this direction. So what we want is the component of this guy along the incline. So this mg can be written as the component along the incline is mg sine theta, and the component perpendicular to the incline is mg cosine theta. Okay, so you saw that from a lecture. Well, this force is being balanced by the normal force. And since the box is not coming off the plane, we know that the normal force is balancing that, so we are not worried about that. We are only interested in this motion, the motion along the incline. Okay, since it's accelerating upward, this force has to be greater than mg sine theta. Okay, so let's take that direction to be positive. So F minus mg sine theta, theta is the angle of the incline, is mass times the acceleration. This is Newton's second law. Newton's second law, remember, is the net force acting in any direction is mass times the acceleration in that direction. Yep. All right, so what is it that we want to find? What force? F equal to mg sine theta plus ma. Okay, that's the force you need to apply. And well, let me do g sine 30 plus 2, and I'll write 2 in terms of, you guys can put numbers, but so the force you need to apply is 0.704 mg. Yes, 70% the weight of the object. Okay. So what is this incline doing for you? If you wanted to lift the object straight up and give it an acceleration of 2 meters per second square, the force you would have to apply is mg plus that, which would have been 1.2 mg if you lifted it straight up. By going up the incline, you're only applying a force of 70% the weight of the object. Okay? So this incline is a machine. That's what machines let you do. They let you do the same thing by applying a smaller force. But of course, if you went straight up, you would have to cover a smaller distance. By applying the smaller force, you're having to cover a greater distance. Okay? So that's what's going on.
Is the force the same for any end or object at that angle? So
No, so
say you're pushing a car.
no, so that's the weight of the object.
Yeah, right. So you still need like 70%. It doesn't matter what the mass
Right,
of the
right.
object
Yeah,
is.
yeah, very good. Yeah. So did you understand? For any mass, as long as it's frictionless, you're applying 70% the weight. Okay. If you wanted to apply a smaller weight, what would you have to do? A smaller force.
Increase the angle.
I'm sorry?
Increase the angle.
Decrease the angle. So you increase the angle, this is the upper limit. Okay? So, so in machine language, you say, smaller the angle, greater the mechanical advantage of this machine. Okay? All right, so this problem says the velocity of a 3 kg object at t equal to 6 seconds and t equal to 8 seconds are, so there's the initial velocity, there's the final velocity. If the object is moving at moving with constant acceleration, or at constant, what is the force acting on it? Right, let's first find the acceleration. The acceleration is final velocity minus initial velocity, okay, over the time over which this acceleration happened. Okay, so final velocity is minus 2I plus 4k minus 3I minus 6j plus 4k. And this change in velocity happened over 2 seconds. So minus 5I plus 6j and 0k over 2 seconds. Okay, so that is the acceleration of the object. And the force acting on the object is just mass times acceleration. 3 kgs times. And the units of forces are newtons. Okay. Kg meters per second square is newtons. Okay, this problem says two forces are acting on a 5 kg object that moves with an acceleration of 2 meters per second in the positive y direction. So they give you the magnitude of the force, of the acceleration and its direction. So let's write down the acceleration is 0I plus 2j. Okay. If one of the force acts in the positive x direction and has a magnitude of 12 newtons. So one of the forces is 12I plus 0j newtons. What is the magnitude of the other force? Okay, so we have F1. Okay. And so the acceleration is in this direction. Okay. So what direction should the other force be in to make it accelerate in this direction? See, it's accelerating in this direction. The acceleration doesn't have an x component, so you need a force that is canceling the x component, and it has to have a y component as well. Okay? So F2 needs to be somewhere there. Okay. All right. Well, what does Mr. Newton tell us? F1 plus F2, those are the only two forces acting on the object, is mass times acceleration. So F2 is ma minus F1. Mass is 5 kgs and acceleration is 0I plus 2j minus 12I plus 0j. So this is minus 12I plus 10j newtons. Okay. So there's F2. You see, we'd already guessed the x component cancels that, the x component of that cancels that, and there's the y component of this force which is giving you that acceleration. Okay. All right, guys, that